Okay, so today we will be discussing trigonometric identities. Okay. Basically, we'll be talking about most important formulas over here, which we are going to call it as a identities. So the very first formula is sin square x plus cos square x is equals to 1. Okay, how we got this result, I am going to show it over here. Meanwhile, let me write the other formulas also. Then all together we will be discussing about how exactly we got each and every formula. I can see everyone has turned off their camera. Why? Please turn it on. Sec square x minus tan square x is equals to 1. Next one is cosec square x minus cot square x is equals to 1. Let's see how we got this formula quickly. So the first formula, okay, suppose we are having a right angle triangle ABC. Okay, this is 90 degree. Randomly we are drawing this right angle triangle. Suppose this angle C is, let's say this is X. Okay, this angle C we are representing with a variable X. We are calling this angle as X, or you can call it theta. Okay, so if you will focus over here, can you see sine? Suppose we have to find sine X. Can you tell me what will be sine X? Which side by which side? Yes, who will say sin x will be opposite over hypotenuse? So can we write AB over AC? Can we? Can we? Yes or no?
Yes, ma'am.
Yes.
Similarly, cos x will be BC over AC. Now, with the help of this two, can you see this formula? That if we will do the square and if we will add both of them, definitely we are going to get 1. Yes or no? If you are not able to if you are not able to get it from here, let me show it. If we will be taking sin square x plus cos square x, that means AB by AC whole square, BC by AC whole square. Okay, if you will do the simplification over here, denominator LCM will be AC square, numerator will be AB square plus BC square. Now let's focus in the triangle AB square plus BC square. Can we say by Pythagoras theorem it is AC square? Can we? Can we say that AB square plus BC square is nothing but AC square? Can we? Can we?
Yeah.
Yeah. So if we can say that, then AC square by AC square is just 1. So from here only this result came just from right angle triangle of the trigonometric ratios formula. So the first formula is sin square theta plus cos square theta is equals to 1. In this formula, we just have to be careful that this angle has, if that is x, this one has to be x. Okay, if you are saying that, if you are saying that sin square A plus cos square C is equals to 1. This is completely incorrect. Here both the angle has to be exactly same. That is the one and only one criteria. Sin square A plus cos square A is 1. Sin square C plus cos square C is 1. If you are maintaining the same angle, then only both added together will generate the result 1. That's what the formula says, and that's what we have seen in our proof also. Okay, now this proof can come in exam. You will be able to prove it, right? Right? Yes, everyone, will you be able to prove it?
Yes.
This is the proof we
Yes.
have done over here. Don't get confused that I have not taught you the proof. This now only we proved it. Okay, this is how we have proved it. So you should, like, you must be able to prove it. Now let's sec square x minus tan square x. This we have to prove. So see, sine square x plus cos square x is equals to 1. We already know the first formula, and from where it came we know that from where it came. The next formula we have to prove it, and in the next formula sec is there, tan is there. Okay, so let's, here you can see sine, and we want tan, we want sec. So to make it tan, let's divide both side by cos square x. Okay, so this is one of the formula which we know already, which we are having in hand. Now here dividing both side by dividing both sides by cos square x. Let's divide. Automatically we will get the other formula. Sin square x by cos square x plus cos square x by cos square x is equals to 1 by cos square x. Sin square x by cos square x is nothing but tan square x. Cos square by cos square is just 1. 1 by cos square is sec square x. We are done with the next formula. Can you see it? 1 is equals to sec square x minus tan square x. Can you see it? Or sec square x minus tan square x is equals to 1. This is the next formula. We are done with the proof. Can you see it? We started with the formula which we are having in hand. Here sine we were having, and we wanted to create tan over here. Hence we divided by cos on both side of cos. Okay. When we did so, we are done with the other formula. We have proved how to get the next formula. Is it crystal clear to all of you?
Ma'am, can you explain this once again?
Sin square x plus cos square x is equals to 1. Already we are having in hand. We want already this one we are having in hand, right, Gungun?
Yes, ma'am.
And we want to prove the next formula. Okay, in this formula, what we did here, sine was reflecting, and the formula which we want to prove is the second formula. See carefully, the second formula sec square minus tan square. So sec is required, tan is required. So in our mind, it's there that we want to create tan, we want to create sec. So with the help of this circled sign, if you want to create tan, obviously you need to divide by cos. Yes or no? Do you
Yes,
know that
ma'am.
tan means sine by cos?
Yes, ma'am.
That's why we have divided both sides by cos square x. Okay, check it. So sine square x by cos square x. Cos square x by cos square x. 1 by cos square. This is how we do the division on both sides. Okay. Basically we do the division when you are having a plus b is equals to c. Wait. A plus b is equals to c, and here if you are dividing both side by z, that means you are dividing like a plus b you are dividing by z, and c you are dividing by z. Eventually you can write it as a by z plus b by z, and here c by z. Are you getting it?
Yes, ma'am.
Okay, so this is how we have done the division. It's completely fine. I'm just showing you the details, because most of the time when I do it on screen, when you will be doing it by yourself, of course it will be clear to you. Okay, but when I'm doing on screen, it can happen that you are not getting what, like it's, how exactly the next step came. That's why I'm giving this detail. Okay, so tan square x we got this cos square by cos square is 1. 1 by cos square is c. And we got the formula. Can you see? 1 is equals to sec square x minus tan square x. That means sec square x minus tan square x is just 1. We are done with proving the formula. Is it okay, Guru?
Yes, ma'am.
Now we'll be proving the third formula. Still we'll be starting with the first formula. Yes, anyone having any doubt till so far? Anyone having any doubt so far? No. Just a second. Next is we are going to prove the third formula. If you have noted down all formula in one go, these are the formulas. Okay, the third formula we are going to prove over here. Cosec is there, cot is there. With the help of the first formula only, sin square x plus cos square x is equals to 1. Now you tell me, dividing both side by what? Who will say quickly? Please tell me, dividing both side by. We want to create cot and cosec. Can we divide both side by sin square x? Check it. This will become 1. This will become cot square x. And this will become cosec square x. Yes or no?
Yes.
And we are done with the proof. Just a moment. Yeah. So we are done with the third proof. Can you see it? That cosec square x minus cot square x is equals to 1. Yes or no?
Yes.
This is how we have got these three most important identities. Now keep in mind that tan means sin by cos. Cot means cos by sin. Cot is also the reciprocal of tan. Just keep everything in mind because we are going to prove so many. So proofs are there that left hand side is equals to right hand side every time we will be proving. So let's do it now. In this formulas, in this formula, we will not be using the formula as it is. Always we will not be using the formulas as it is. From now onward, when you know that sin square x plus cos square x is equals to 1, you can use it this way also. You can say that 1 minus cos square x means sin square x. This is how we will be using this formula. Or we will say that 1 minus sin square x is cos square x. This is how we will use this formula. See carefully, it came from the same formula. Okay, or we will also be using it this way. We will be saying that under root 1 minus cos square x is just sin x. Under root 1 minus sin square x is just cos x. This is how we will be using this formulas. We are having only 3 formulas in hand, but this is how we will customize it every time whenever we will need it. Okay, so let's start solving the question which is based on proofs. Prove that sec a 1 minus sin a sec a plus tan a is equals to 1. Let's prove it. Okay, whenever you have to prove something, please don't just observe the question and start thinking what can be done, what can be done, how we will go in the right direction. Don't think. Okay, whatever is coming in your mind, start doing. So sec, always we will convert sec, tan, cosec, cot. This always these are the this trigonometric ratio we will try convert in the form of sine and cos. ओके जब भी हमारे पास tan cot sec cosec होगा हम लोग सबसे पहले उसे sin और cos में चेंज करेंगे. Okay, whatever we are supposed to prove, we don't know what to do, we don't know where to go. At first we will see which side, like left side or right side, where exactly like more simplification is possible, and we will pick that side where the simplification we can work. If you will take only the right hand side and if you will start doing something, you won't be able to do anything because one is there. Okay, so left hand side we will be working. Why I am saying these things, because later on so many questions will come where you will like sometime we will be solving right hand side and it will be easier, okay, to show that right hand side we solved and hence we ended up getting the left hand side. Okay, here we will be taking left hand side. Sec a 1 minus sin a. I told you, when you don't know anything, start converting tan, sec, cosec in terms of sine and cos. Okay, so we will be writing this sec as a 1 by cos, 1 by cos a. Okay, 1 minus sine a as it is. This sec a we will be writing 1 by cos a, and tan a we will be writing sine a by cos. Any confusion so far? Every time we will be doing these steps. Any confusion so far?
No.
Okay. 1 by cos A as it is. 1 minus sin A as it is. What will be the LCM for the bracket part?
Cos A.
Cos A. And the numerator will be?
Ma'am, 1 plus sin A.
Yes, as it is. This is what we ended up getting. Now let's multiply all of them together. The rule of fraction says that multiply numerator with numerator and denominator with denominator. So we will multiply. In numerator we are having 1 minus sin a, 1 plus sin a. And in denominator, all are in multiplication. All are in multiplication, and we are just trying to give it. Yeah. All are in multiplication and we are just trying to multiply all of them together. Rule of fraction chapter which you have learned in class 3, class 4, that 1 by 2, into 7 by 5 into 8 by 9. Let's multiply numerator with numerator and denominator with denominator. That's what we are going to do into it. Okay. So 1 minus sine A, 1 plus sine A over cos A into cos A. Any confusion so far? Any confusion?
Ma'am, could you please explain?
Yes. Anyone? Yes, Harshit, you are not getting this step?
Yes, ma'am.
Okay. Now in numerator, can you see A plus B, A minus B type of structure is there which you have learned in maybe class 9. A plus B, A minus B. Can we write it as a square minus B square?
Yes, ma'am.
A square minus B square. अभी अभी हमने जो फॉर्मूला प्रूफ किया वो फॉर्मूलाज तो यूज करना ही है. Along with that we will be using A plus B whole square formula, A minus B whole square formula, A plus B whole cube formula, A minus B whole cube, all the formula which you know already, of course. So in denominator we are having cos square. We are getting in numerator 1 minus sine square. And now only I told you. Let's get back to what I told you. Now only I told you that from this formula we are getting this 1 minus sine square x is equals to cos square x. Can you see it?
Yes, ma'am.
Everyone can, are you getting it? From this formula we got this one.
Yes.
We will be using it over here. 1 minus sine square A means cos square A by cos square A, and hence we got 1. Yes or no?
Yes, ma'am.
See how easily we did. How you will get to know how to do it. Start doing. Whatever is coming in your mind, just keep on doing. The problem will guide you where to go. Okay? Is it crystal clear to all of you?
Yes.
Yes, ma'am.
Now the questions will be like this. 9 sec square A minus 9 tan square A. Value will be 9. You will take out common. Will it be just a formula, nothing else? If you will take 9 common, will it take the shape of formula? 3 formula we have discussed just now. One of them was sine square x plus cos square x is equals to 1. Next was sec square x minus tan square x is equals to 1. Third one was cosec square x minus cot square x is equals to 1. And I am asking you what will be the value over here, the question mark at the place of question.
1.
Will it be 1 or will it be 9? 9 you will take out common
9.
and then
9.
yes, it will be 9. Okay, when you will take out 9 common, result is just 1. 9 into 1 is 9. So 1 will also be there in the option, but be careful. You are multiplying 9 with 1. Now this 1 plus tan theta plus sec theta 1 plus cot theta minus cosec theta is equals to, what will be the result? Options are option A 0, option B 1, option C 2, option D minus 1. Yes. What will be the result? Let's try solving it. I told you when you are not getting anything, when anything is not working, let's try converting tan in terms of sine and cos, sec in terms of sine and cos. Okay, let's do that. So, sine by cos, 1 by cos, 1 plus cot. Cot means cos by sine, minus 1 by sine. Any confusion so far?
No.
Okay. Here, what will be the LCM? LCM will be, and what will be the numerator? LCM will be cos theta, right? And what will be the numerator then? Yes? Tell me what will be the numerator.
It will be the same for the first one.
Will it be same? 1 plus sine plus 1?
It will be cos theta plus sin theta plus 1.
Exactly. It will be cos theta.
And for the next one, it will be sin theta plus cos theta minus 1.
So this is what we are having for now. Denominator is just sine theta into cos theta. Numerator is, does it look like a plus b, a minus b again? Is it so? If I will give here bracket, now does it look like a plus b, a minus b? Yes
Yes.
or no? Can we write a square minus b square? Can we?
Yeah.
This this is where we have to use the formula of a plus b whole square. Okay, a square plus 2ab plus b square minus 1. I signed to my first. Any confusion so far? ध्यान से देखो ये दोनों मिलके 1 बनाए. Cos square plus sin square is nothing but just 1. If the angle is same and here the angle is same, can we say that cos square theta plus sin square theta is just 1? Can we? Can we? This 2 is sky color part, this 2 is sky underlined part sitting together will generate only 1. Can we say that? Can
Yeah.
we? Yes, we can say that. One gone.
We get an answer.
The result is, see, we can see the result. The final answer will be which option?
E.
Final answer you can see over here. 2 is the final answer because here we are having 2 cos theta sin theta. Okay, theta I have not written because I am just trying to show you in the denominator sin and cos we can take, and everything this all will get cancelled out. This will be the result. So we don't know what to do. There are another way also to do the same thing. Okay, but I'm telling you, when you don't know what to do, maybe here cot you could have written in terms of tan, maybe any other approach you would have applied for the same and you would have got this too. That is fine, but I'm telling you, when you don't know anything, always this sine cos will work. Okay, just write at the place of tan sine and cos, at the place of cot just cos and sine. Okay, just convert all the other trigonometric ratio in terms of sine and cos. You will get the direction and just keep on going in that direction. Just try simplifying it. So don't focus on what you have to prove. Don't focus on what you have to find. Just try simplifying it. At the end, you will find that you ended up getting the result or you ended up proving it. Okay. All the question in this exercise will be solving like this. Next is 1 plus tan square over 1 plus cot square. Options are given. Yes. What to do over here? What to do over here? Anyone? Let's do it our always usual way. When you don't know anything, convert it in sine and cos. So it will be 1 plus sine square a by cos square over 1 plus cos square a by sine square. Let's simplify numerator and denominator. It will be 10. What will be the LCM for the numerators part? What will be the LCM? Cos square.
Yes.
Here we will be having cos square plus sine square.
Mm.
Here also, I'm showing you the other way also. Sine square. Here we'll be having sine square plus cos square. But this is just the formula. Sine square plus cos square is 1. 1 by cos square. Sine square plus cos square is 1. 1 by sine square. Okay. When we will simplify it, we'll be getting what? Tell me. When we will simplify it, what are we going to get? Which option? Yes. Will it be sine square a by cos square a? This will go in the numerator. That is just tan square a. Yes or no? Yes. Are you getting it? Students. Harshit, Aisha, Gungun.
Yes, ma'am.
Yes,
Getting
ma'am.
it? Arish, Fazan,
Yes.
I'm asking, you have to tell me. Yes, you all are getting. Yes, Maha,
Yes, ma'am.
Janab, getting.
Yeah.
So yeah, this is one of the way, and another way we have not learned only one formula. We have learned three formulas. The first one was sin square x plus cos square x is equals to 1. Next one was sec square x minus tan square x is equals to 1. And the third formula was cosec square x minus cot square x is equals to 1. These are the three formula you have just now we have proved, we have learned. So we can use directly the second and the third formula over here. The second formula 1 plus tan square. Can we write 1 plus tan square as a sec square? Here. Yes or no? By using second formula. Formula number 2.
Yes.
Can we? And by using third formula number 3, can we write it as a cosec square x?
Yeah.
Yes. But now, still we have to convert it in terms of sine and cos. Then only we will get the idea whether it is cot, whether it is tan, whether it is what. Okay, so sec we have to convert. Eventually, you have to convert it in terms of sec will be 1 by cos square x. It was not x, it was a. Over cosec is 1 by sine square. And you can see we ended up getting the same result. This is this one and this one is same. Did you see? From here only we'll be getting tan square x. Getting it?
Yes.
So this is how always this approach will work of converting in terms of sine and cos when nothing is clicking. You have these questions in your book. Cosec theta minus cot theta whole square is equals to 1 minus cos theta over 1 plus cos. I think it's not there, right? It's not there, right? Please check it and let me know. Give me a moment.
It is there.
It is there, ma'am.
It's there.
Okay, let's do it. Okay. So we have to show that the left hand side and right hand side is nothing but just the same thing. Okay, let's see how to show it. So there are few ways. What we can do, we can work on left hand side, and we will see whether exactly we are getting right hand side. It looks like exactly if we will not get right hand side, it's totally okay. We will solve, we will simplify right hand side also, and we will see the result which we have already generated from the left hand side. Is that result is same as the result which we are going to generate? Like left hand side will be solving, right hand side will be solving, and both the result has to be same. That's what I'm trying to say. So there are three ways to prove any like proof based question. You should take left hand side and automatically you will get right hand side. Or you should take right hand side, automatically you will be getting left hand side. Or sometimes we have to solve left hand side also and right hand side also. Okay, so this belongs to, this is going to fall in which category? Let's see. Let's say we are going to take left hand side. Okay, cosec theta minus cot theta. We don't know what to do. Okay, we don't know what to do, but I told you, when you don't know what to do, you are having one option. Okay, just you can convert it in terms of sine and cos, or here if you will look closely, can you see it looks like a formula? Can you see?
Some a minus b whole square we can do.
Yes, you can also use the formula, but after using the formula, like again we'll be having this type of arrangement, cosec square minus 2 cosec cot and then plus cot square. Okay, here this one and this one is not making formula. Okay, because the number third formula was cosec square minus cot square is there. Plus cot square is not there. Okay, okay, so this is one of the possibility which is coming in our mind. The next possibility which is clicking is, we can also convert it in terms of sine and cos, and we can work on that. Maybe the other side, 1 minus cos, 1 plus cos, we will be getting like that. Let's check it. So if we will convert this as a 1 by sine theta and this as a cos theta by sine theta. I told you, when you are not getting anything, this will most of the time, 99% of the time will work. Okay, so let's see. So we are, if we will try simplifying it, can you see sine theta is the LCM over here and 1 minus cos theta is the numerator's part over here, but everything is still having a square. Now exponent of the exponent rule says, law of exponent says that if power is there and numerator and denominator's term are there, we can distribute the power to the numerator's term and to the denominator's term. So we will give the power, take the power. Now the denominator sine square theta, we are having one formula, that is sine square theta plus cos square theta is equals to 1. Every time, again and again, we will be using this formula. So at the place of sine square theta, can I write 1 minus cos square theta? Can I write at the place of sine square theta 1 minus cos square theta? Yes or no?
Yes.
1 minus cos square theta. Why we did so? Because the other side cos and cos was there in the numerator and denominator. Now the denominator's part, does it look like a square minus b square? Yes or no? Does it looks like a square minus b square? So we can write it a plus b, a minus b, and numerator as it is. See, 1 minus cos theta, we will cancel it with 1 minus cos theta from the numerator's part. This one and one of the 1 minus cos theta will get cancelled out and we are done with the proof. Can you see it? Can you see it?
Mm.
This is what we wanted to prove, yes or no?
Yeah.
Okay. So yeah, here we have taken left hand side and automatically we ended up proving the right hand side. Okay. Sometime we will be working on right hand side and it will be easier to prove left hand side. Sometimes both sides we have to work on. So this is how we will be doing it. If we would have applied the formula of a minus b whole square, then I told you that you just expand it, you will see that you are not getting anything from there, and you are not getting now where to go. So better do this way every time, doing the same type of calculation. Getting it?
Yes.
Yes. Okay.